Okay, let's actually build a full-blown recommender system that can look at all of the behavior information of everybody and what movies they rated on every movie and use that to actually produce the best recommendation movies for any given user in our data set. Kind of amazing, and you'll be surprised how simple it is. Let's go. Okay, let's put it all together and actually do full-blown item-based collaborative filtering where we can recommend movies for any user based on all the behavior of what everybody rated every movie. How amazing is that? What's really amazing is how simple Pandas makes it to do. So let's walk through it. Okay, so let's start off by importing the movie lens dataset that we have. Again, we're using a subset of it that just contains 100,000 ratings for now, but there are larger datasets you can get from grouplens.org up to millions of ratings, if you're so inclined. Keep in mind, though, when you start to deal with that really big data, you're going to be pushing the limits of what you can do in a single machine and what Pandas can handle. So, I do have other courses on techniques like Spark and MapReduce that can handle much larger scale recommendations. So if you're curious, go check those out. But for now, let's work with this. So just like before, we're going to import the u.data file that contains all of the individual ratings for every user, what movie they rated. And then we're going to tie that together with the movie titles so we don't have to just work with numerical movie IDs. Go ahead and do that, and we end up with this data frame. Way to read this, for example, user ID 308 rated Toy Story 4 stars and user ID 66 rated Toy Story 3 stars. And this will contain every rating for every user for every movie. And again, just like before, we use the wonderful pivot table command in Pandas to construct a new data frame based on that information, where the index, each row, is the user ID, and the columns are made up of all the unique movie titles in my data set, and each cell contains a rating. So what we end up with is this incredibly useful matrix, sparse matrix, that contains users for every row and movies for every column, and we have basically every user rating for every movie in this matrix. So user ID 1, for example, gave 101 Dalmatians 2 stars, and again, all these NANs, not a numbers, represent missing data. So that just indicates, for example, user ID 1 did not rate the movie 1900. Okay, so again, very useful matrix to have. If we were doing user-based collaborative filtering, we could compute correlations between users, between each individual user rating vector to find similar users. And since we're doing item-based collaborative filtering, we're more interested in relationships between the columns. So by doing a correlation score between any two columns, that will give us a correlation score for a given movie pair. So how do we do that? It turns out that Pandas makes that incredibly easy to do as well. It has a built-in core function that will actually compute the correlation score for every column pair found in the entire matrix. It's almost like they were thinking of us. So let's go ahead and run that. It's a fairly computationally expensive thing to do, so it will take a moment to actually come back with a result, but there we have it. So what do we have here? We have here a new data frame where every movie is on the row and in the column. So we can look at the intersection of any two given movies and find their correlation score to each other based on this user rating data that we had up here originally. How cool is that? So for example, the movie 101 Dalmatians is perfectly correlated with itself, of course, because it has identical user rating vectors. But if you look at 101 Dalmatians' relationship to the movie 12 Angry Men, it's a much lower correlation score because those movies are rather dissimilar. Makes sense, right? So I have this wonderful matrix now that will give me the similarity score of any two movies to each other. It's kind of amazing and very useful for what we're going to be doing. Now, just like before, we have to deal with spurious results. So I don't want to be looking at relationships that are based on a small amount of behavior information. So it turns out that the Pandas core function actually has a few parameters you can give it. One is the actual correlation score method that you want to use. So I'm going to say use Pearson correlation. But it also has a min periods parameter you can give it. And that basically says, I only want you to consider correlation scores that are backed up by at least, in this example, 100 people that rated both movies. And that will get rid of the spurious relationships that are based on just a handful of people. A little bit different than what we did in the item similarities exercise where we just threw out any movie that was rated by less than 100 people. What we're doing here is throwing out movie similarities where less than 100 people rated both of those movies. Okay, so you can see now that we have a lot more NANs in the resulting matrix. In fact, even movies that are similar to themselves get thrown out. So for example, the movie 1900 was presumably watched by fewer than 100 people. so it just gets tossed entirely. 101 Dalmatians, however, survives with a correlation score of 1, and there are actually no movies in this little sample of the data set that are different from each other that had 100 people in common that watched both. But there are enough movies that survive to get meaningful results. So what do we do with this data? Well, what we want to do is recommend movies for people. So the way we do that is we look at all of the ratings for a given person, find movies similar to the stuff that they rated, and those are candidates for recommendations to that person. So let's start by creating a fake person to create recommendations for. So I've actually added a fake user, ID number 0, to the movie lens dataset that we're processing by hand. And that kind of represents someone like me who loved Star Wars and The Empire Strikes Back, but hated the movies Gone with the Wind. So this represents someone who really loves Star Wars, but does not like old-style romantic dramas, okay? So I gave a 5-star rating to Empire Strikes Back and Star Wars, and a 1-star rating to Gone with the Wind. So I'm going to try to find recommendations for this fictitious user. So how do I do that? Well, let's start by creating a series called Sim Candidates, and I'm going to go through every movie that I rated. So for I in range 0 through the number of ratings that I have in my ratings, I am going to add up similar movies to the ones that I rated. So I'm going to take that core matrix data frame, that magical one that has all of the movie similarities. I am going to create a correlation matrix with my ratings, drop any missing values, and then I'm going to scale that resulting correlation score by how well I rated that movie. So the idea here is I'm going to go through all the similarities for The Empire Strikes Back, for example, and I will scale those all by 5 because I really liked The Empire Strikes Back. But when I go through and get the similarities for Gone with the Wind, I'm only going to scale those by 1 because I did not like Gone with the Wind. So this will give more strength to movies that are similar to movies that I liked and less strength to movies that are similar to movies that I did not like. Okay? So I just go through and build up this list of similarity candidates, recommendation candidates, if you will, sort the results, and print them out. Let's see what we get. Hey, those don't look too bad, right? So obviously The Empire Strikes Back and Star Wars come out on top because I like those movies explicitly. I already watched them and rated them. But bubbling up to the top of the list is Return of the Jedi, which we would expect, and Raiders of the Lost Ark. So let's start to refine these results a little bit more. We're seeing that we're getting duplicate values back, so if we have a movie that was similar to more than one movie that I rated, it will come back more than once in the results. So we want to combine those together. So if I do in fact have the same movie, Return of the Jedi for example, was similar to both Star Wars and The Empire Strikes Back, maybe that should get added up together into a combined, more strong recommendation score. So let's go ahead and do that. We're going to use the group by command again to group together all of the rows that are for the same movie, and we will sum up their correlation scores. And look at the results. Hey, this is looking really good. So Return of the Jedi comes out way on top, as it should, with a score of 7. Raiders of the Lost Ark, a close second at 5. And then we start to get to Indiana Jones and the Last Crusade. And some more movies, Bridge on the River Kwai, Back to the Future, The Sting. These are all movies that I would actually enjoy watching. I actually do like old school Disney movies too, so this isn't as crazy as it might seem. So the last thing we need to do is filter out the movies that I've already rated because it doesn't make sense to recommend movies you've already seen, so I can drop any rows that happen to be in my original ratings series. Look at the top 10 results. There we have it. Return of the Jedi, Raiders of the Lost Ark, Indiana Jones, all the top results for my fictitious user, and they all make sense. Seeing a few family-friendly films, Cinderella, Wizard of Oz, Dumbo creeping in, probably based on the presence of Gone with the Wind in there. Even though it was weighted downward, it's still in there. It's still being counted. And there we have our results. So there you have it. Pretty cool. We have actually generated results, recommendations for a given user, and we could do that for any user in our entire data frame. So go ahead and play with that if you want to. Next, I want to talk about how you can actually get your hands dirty a little bit more and play with these results. Try to improve upon them. All right, I'm pretty excited by these results so far. They're actually looking really reasonable. There is room for improvement though, and that's going to be my challenge to you in our next lecture. We'll talk about some ways that you might actually extend and build upon this IPython notebook and actually make better movie recommendations than what I gave you to start with. So there's a bit of an art to this. You need to keep iterating and trying different ideas and different techniques until you get better and better results. And you can do this pretty much forever. I mean, I made a whole career out of it. So I don't expect you to spend the next, 10 years trying to refine this like I did, but there are some simple things you can do. So let's talk about that.